This video is called Solving Inequalities with Multiplication and Division. Now, in the last video, you learned how to solve inequalities that involved addition and subtraction. Now let's look at what happens when you do multiplication and division across inequalities. Let's say I have the inequality 3 is greater than 2. We know this is true. What if I want to multiply both sides of this inequality by 4? This would give me 12 is greater than 8. Is this still true? Yes. What if I have the inequality 3 is greater than 2, and I decide to multiply both sides of it by a negative 5. 3 times negative 5 is negative 15, and 2 times negative 5 is negative 10. Is this inequality still true? Well, it's not. We know that in negative numbers, negative 15 would be less than negative 10. So, the rule is when you multiply or divide an inequality by a negative number, you need to flip the sign for it to be true. So this is not true, but this is. So I flipped the sign. Let's apply this. If you multiply or divide both sides by a negative number, you must flip the inequality sign. Okay, this is only true of multiplication and division, not addition and subtraction. So here's our rule. And here's our first example. We have x divided by 1 4/10 is greater than negative 10. Now, we know that to undo division, we need to multiply. So I'm going to multiply this by 1 4/10. And I'm going to multiply this side of the inequality by 1 4/10. Notice I'm using a positive number, so I don't have to worry about flipping the sign. Over here, these will cancel out, and I'm left with x is greater than, I do have a negative 10 times 1.4, so I'm going to get negative 14 as my answer. Even though 10 was negative, I don't need to flip my sign because I multiplied both sides by a positive integer. This would be the transformation principle of multiplication for inequality. Now I need to graph this inequality. Negative 14, 1 greater, 1 less. X is greater than, not equal to, so I'm going to use an open circle. And I'm going to draw my arrow to show greater than, that any number greater than negative 14 is a solution. Let's do another example. Negative 3 5/10 x is greater than 14. To undo negative 3.5 times x, I'm going to have to divide by negative 3.5 on both sides of my inequality. Notice now that I'm dividing both sides by a negative. That means I have to flip the sign. Here I have x. Over here I have negative 4. So x is less than negative 4. This would be the transformation principle of division for inequality. Let's graph it. Negative 4, 1 greater, 1 less than. X is less than, so I'm going to use an open dot. And I'm going to draw my arrow to show that my solutions are less than negative 4. And this would be my graph for this inequality simplified. Let's do one more example. I have negative 10 and 7/10 is greater than x divided by 4. I'm going to start by undoing my division of 4, which means I need to multiply both sides by 4. I'm multiplying by a positive integer, so I do not need to flip my sign. Over here, 4's cancel out. I'm left with an x. 4 times negative 10.7 gives me negative 42.8. Now be careful when graphing this type of inequality. Notice my variables on the right side. This really or truly reads x is less than negative 42.8, or negative 42.8 is greater than x. If it's simpler, rewrite it so you can graph it. My central number will be negative 42.8. Now notice there's a decimal here, so 1 greater would be negative 42.7. 1 less would be negative 42.9. There's no equals, so I'm going to use an open circle. X is less than, so I'm going to draw my arrow to the left. So this is this inequality graphed. Now, there are 3 problems for you to try. And this was the video on solving inequalities with multiplication and division.